So next step in the implementation of our stack is that we would like to keep some default size. What if the default size was 1? To providing an array of one integer, right? So the default size is 1 and allows us to store only one integer, right? So instead of having multiple integers like this to begin with, we have only one. So the size of this array is just like this element right here, just one element. That's something that suggests that we can always, it can be 5 or 1,000, but eventually we may exhaust the space. And so how do we create a stack which allocates memory dynamically? So this is where we can switch over to the next version of our stack. Let's do it this way. We just basically say file, close the solution, because we'd like to work on the next version of our stack, and say file, new project, right? And go and create another project, which will be week 09 stack version 2. Okay, how about that? Create version 2. And this time, what I will do is that in my junk folder where I keep my projects, I'm going to go to version 1 and simply steal the source, right? I'm just going to right click and say copy, okay, and go to version 2, and instead of starting like from scratch, basically copy and paste in this project, copy and paste the source with all of the 3 files, right? So I have the implementation file for my stack class, the header file which declares the stack, and of course the main driver program written inside main. So this time I created stack version 2. Again, it's an empty project, view solution explorer, source file list is empty. So I will right click and say add existing item, and this time under my stack version 2 I have the source which I copied over, and I'm going to say I need to add stack.cpp add, and then also go back and say add existing item and main.cpp, but I will not include .h. Header files are included by the preprocessor using the pound include, and I'm not concerned with the header file. All I need to have is one implementation file and another implementation file, the 2 implementation files. Okay, so this will be my starting point for the next version of the stack, which is supposed to accommodate as much or as many elements as needed, and I will still go to to my header file, and actually let me just open all of the files. And if you're using Visual Studio, it's easy to say open document when you have the correct include directive part of your source file. It's very easy to do. Otherwise, you can just go to the source directory where you're storing your files and simply like drag and drop and open it in your source editor or something similar, right? Or you can just say file open and point to the header file and open it in your environment. So this time the problem is on this line. Memory block is using the default size, and that obviously is not very flexible and even absolutely questionable when it becomes like a small number, because the usefulness of this stack class is basically drops tremendously. It's not that good anymore. So what we should probably try using instead is this. We can say then, when we say int stack, right, st, what we would like to do is create our object, which is our stack someplace in memory. But at the same time, so we have like the top of stack, right, integer right here. But instead of hard-coded memory block, we need to say like memory block and make it a pointer to some dynamically allocated array, right? So we want this array to be dynamically allocated at runtime, and we would like to tell the compiler and the runtime environment how much memory we need at any given time. How can we make the switch? We can simply say that memory block is no longer an integer array or an array of default size integers, right? So instead, the memory block simply becomes a pointer to the first integer in this dynamically allocated memory. And so that's fine. The next step, I can close this Solution Explorer view. I don't need to save some space, right? So go to the next tab group, and this is my implementation for the stack, right? Pretty much everything should remain the same. Can I use square bracket notation to dereference pointers such as memory block? Yes, of course I can, right? So I do this in two places, push and top, right? Here I simply just access memory. If memory block before was an array of integers, memory block anyway contained the address of the first integer in that array. So now it just the pointer supports exact syntax because the pointer uses universal. It points to the first integer, but if you use the square bracket notation, it points you to next elements in that supposedly memory block. What should happen is that perhaps the constructor now needs something like this: allocate memory, right? And I need to say how much memory I want to allocate. And perhaps the default size would be my initial attempt to say, how about we allocate memory with whatever the default size comes with. Okay, so allocate memory becomes an internal implementation function. It would be useful to keep it away from the users of our stack, so we can say private, right? And privately add allocate memory as a function, which takes an integer block size, right? So it basically knows how much memory to allocate memory. So this is, and perhaps it can return a void pointer, allocate memory. So it's supposed to basically go ahead and somehow claim this memory from the system, and of course have the memory block pointing to that memory. Okay, so as before, the next step is to say, all right, we need this function, allocate memory. Control C, copy the function prototype, go to the implementation file, stack.cpp, and I will place it, you can place it anywhere. I can place it next to my constructor where I can clearly see the attempt to allocate that memory dynamically, and then I will write the implementation. Again, the usual step is to use the class name to prefix the name allocate memory by its name, so that allocate memory belongs to the scope of our class, and of course get rid of the semicolon, right, and replace the semicolon with a pair of braces. And now think what we need to do now, right? Because this memory block to begin with is just probably containing some garbage value. The constructor is responsible for populating it with something meaningful, with something that the program can legally access. So what we need to do is simply to say memory block, which is a pointer, equals new int, and specify how much integers you want to create, simply block size. Okay, so it's very simple. So we used to have a static array of the default size. Now we have the dynamic array, which basically says, let's just at runtime, when the user creates the stack, we're going to go and tell the system, we want to have this many new integers, 100, 200, 1 million, or just one, doesn't matter. We're gonna say that we want this to happen. Okay, so at a minimum, do something like that. My next concern is that if now we want to make this object kind of smart and convenient to use, basically push should probably check for the capacity, like how much space is being already allocated. Do we need more space? Or can we still use already existing space? So I am thinking that we need another important variable in the implementation of our stack, which says int capacity. Right? We need to have the capacity, and every time the new memory block is allocated with whatever block size is, we need to say that our capacity is this block size. Whatever we just allocated, this is the capacity. That's why, anticipating this extra steps, the set of extra steps, I created a separate private function as opposed to writing this code directly inside my constructor, right? So the constructor of integer stack, this only default constructor that we have, basically says allocate memory and calls this function, which in turn creates a block of integers and remembers what the capacity is. So in addition to just dynamically allocating this new memory block, now I also have the capacity data member, which I'm adding to my container of integers, right? Which remembers how many integers have I allocated, right? So it basically keeps the size of this memory block, right? So it knows how many I have allocated. And initially, of course, I pass in the default size, right? So, and it should be pretty much working well even when the size is 1, right? So what? Create a block of 1 integer and the capacity will be 1. Right? Which is kind of extreme. Maybe we want to change that to a bigger value to make it more efficient, that we don't have to do anything crazy with that right away. But at the same time, right, so let's just perhaps save the segment and switch over to the next one.